Here, inside this Japanese factory, over 600 of the iconic Mazda CX-5 are built every single day. The shaped parts are now joined together by welding, where the beautiful shape of the car comes together. Welding is carried out with high precision, as it significantly affects the car's stability. Robots are used not only for cost efficiency, but mainly because they ensure greater accuracy. Then, with a human touch and visual inspection, the inspector confirms the quality. Mazda CX-5 has become a core model for Mazda, accounting for approximately 25% of its annual sales. Over 240,000 of these vehicles are produced here each year. Right now, you're watching the installation of a large panoramic sunroof from the interior side of the vehicle. At this stage, the roof system arrives as a fully sealed, pre-assembled unit from specialized suppliers, designed for perfect fitment and structural integrity. This facility is one of Mazda's most important production sites and serves as a key hub for building the brand's core SUV models. Interestingly, at the Hiroshima Ujina plant, Mazda deliberately avoids full automation. Instead, the production philosophy is built around a balance. Machines are used for repeatable precision and consistency, while humans are responsible for sensitivity, judgment, and fine quality perception, a combination that defines Mazda's unique approach to manufacturing. To meet worldwide demand, the Hiroshima plant produces over 240,000 units per year, with an average output of more than 600 vehicles every single day. As each vehicle reaches the end of the line, it enters the final stage of production, a detailed quality inspection conducted in a specialized LED tunnel. This quality control department serves as the final checkpoint before a vehicle leaves the factory, effectively acting as the last line of defense for product quality and consistency. This environment is designed to highlight even the smallest surface imperfections under controlled lighting conditions. Through extensive training, they develop the ability to visually detect extremely fine panel gaps measured in fractions of a millimeter, ensuring exceptionally high manufacturing precision. Quality inspectors at the plant are highly trained specialists who must complete inspections within strict time limits. After robotic assembly is completed, the vehicle undergoes a final human inspection. Skilled workers perform a detailed visual and tactile check, ensuring that all joints, seams, and structural elements meet strict quality standards. Right here, inspectors carefully check and fine-tune the lighting systems, gauges, and listen for any unusual noises before confirming that both the accelerator and brake pedals respond properly. This particular Mazda is not the primary model produced at Hiroshima, so annual production volume at this plant is relatively limited, at around 70,000 units per year. The main production hub for the CX-30 is the Salamanca plant in Mexico, which accounts for more than half of global CX-30 output. Mazda CX-9 production began in 2006 at the Hiroshima plant, specifically targeting the North American market from the very start. The CX-9 is manufactured exclusively in Japan at Mazda's Ujina plant No. 1 in Hiroshima. As a result, it is a Japan-built export-only model, with no regional variations in build quality or production standards. Both all-wheel drive and front-wheel drive versions are built on the same assembly line. The all-wheel drive system is installed during the final stages of production, meaning configuration differences are handled within a single unified manufacturing process, rather than separate production lines. Unlike many global SUVs, this model was never mass-produced in the United States or in other overseas manufacturing locations. Every unit is assembled under the same Japanese production system, ensuring consistent craftsmanship across all markets. The Hiroshima plant itself is a massive industrial complex employing roughly 10,000 workers. The CX-9 also features Mazda's active all-wheel drive system, which combines real-time sensor data with predictive torque distribution. This includes assembly line operators, engine production staff, welding and paint shop technicians, as well as logistics teams, quality control specialists, and engineering support personnel. It functions as Mazda's most important and largest single manufacturing site in Japan. Importantly, the calibration of this system is not only a hardware installation step, it is deeply integrated into the production process itself, ensuring that both mechanical components and electronic control systems work together seamlessly from the moment the vehicle leaves the factory. Mazda uses the Japanese concept of Monozukuri, meaning crafting things with skill and spirit. This stage is called finished vehicle storage and port logistics, and it is a key part of Mazda's export system. At Hiroshima, these yards are located near Ujina Plant No. 1 and No. 2. They are also directly connected to the port logistics zones. Cars are driven to large outdoor parking areas inside the Hiroshima complex. Unlike some manufacturers, there is no need for long inland transport to a separate port. Cars remain within Mazda-controlled areas until they are loaded onto ships. Ships do not arrive every hour. Vehicles are stored until a full vessel load is ready. They are also organized into destination batches, such as for the USA or Europe. This is where the redesign of one of Suzuki's most widely produced vehicle lines begins. Step inside a Japanese Suzuki factory and follow the process behind the Suzuki Wagon R Smile as it comes together piece by piece. From the first stamped panels to final assembly, every stage reflects a system built around efficiency and precision. One of the most striking aspects of the production line is how much it relies on shared platforms and components. The Smile borrows structural elements and design features from other models in the Wagon R family, a strategy that keeps costs down and production flexible. This kind of modular design is a cornerstone of Japan's kei-car manufacturing philosophy. That's still relatively uncommon in this segment and makes getting in and out much easier, especially in crowded parking spaces. Along with that, recent versions lean into a softer, more approachable design that gives the car its Smile personality. Production takes place in major Suzuki facilities, like Suzuki Kosai plant and Suzuki Iwata plant. These plants are central to Suzuki's domestic manufacturing, producing popular mini vehicles such as the Suzuki Alto, Suzuki Spacia, and Suzuki Hustler. Everything about the Smile is shaped by Japan's strict kei car regulations, rules that limit size, engine displacement, and fuel consumption. These constraints push manufacturers like Suzuki Motor Corporation to focus on lightweight construction and clever packaging rather than simply adding more power. Even the assembly process reflects that mindset. The cars are designed so a single worker can easily access all key components, improving efficiency and reducing unnecessary movement on the line. At the same time, features like the sliding rear doors add complexity, making the Smile slightly more expensive to build than the standard Wagon R. Suzuki's factories operate under the philosophy of Kaizen, a continuous effort to eliminate waste and refine every step of production. That's why the same assembly line can seamlessly switch between different models, including the Hustler, Wagon R, and Wagon R Smile. It's a reminder that even the smallest cars can have a massive impact, especially when they're built with this level of efficiency and attention to detail. The Suzuki Wagon R Smile made its debut in September 2021 and quickly stood out in Japan's crowded small car market. Its combination of sliding rear doors and a city-friendly design helped it gain traction fast, with roughly 31,000 units sold in just the first few months after launch, an impressive start for a brand new variant. In Japan's highly competitive coal car segment, the Smile goes head-to-head with top sellers like the Honda N-Box and Daihatsu Tanto, both of which regularly dominate annual sales charts. To stand out, the Smile leans heavily into practicality and ease of use. One of its biggest advantages is the sliding rear doors, which make getting in and out of the car far easier, especially in tight urban parking spaces where traditional doors can be a hassle. Its compact footprint and strong fuel efficiency also make it an ideal choice for daily commuting, short trips, and running errands around the city. Despite its small size, the interior is often described as surprisingly roomy. Clever packaging and a tall, boxy shape create more usable space than you might expect, giving passengers a comfortable cabin for everyday use. The design itself also plays a big role in its appeal. The Smile has a soft, friendly look that feels more approachable and distinctive than a typical economy car. Owner feedback tends to highlight the same strengths. Many appreciate the practical interior layout, easy maneuverability, and solid real-world fuel economy. Some are even pleasantly surprised by how stable and comfortable the ride feels for such a compact vehicle. That said, there are trade-offs. Like most K cars, the Smile is powered by a small 657 cubic centimeter engine, which performs well in city traffic but can feel strained at highway speeds. Long-distance comfort can also be a weak point, with some drivers noting that the rear seats aren't ideal for extended trips. Overall, the Smile excels in the environment it was designed for, urban and suburban driving, where its practicality, efficiency, and user-friendly features make it a strong contender in Japan's small car market. As the painted body moves down the final assembly line, the car really starts to come together. Workers install key components like the wiring harness, dashboard, seats, airbags, climate control system, and the signature sliding rear doors that define this city car. Those sliding doors aren't just bolted on, they require careful manual adjustment to ensure they open and close smoothly and meet strict safety standards. It's one of the more precise steps in the process. Around the same stage, the body is married with the powertrain, meaning the engine, transmission, and suspension are all joined together in a single operation. Once fully assembled, each vehicle is wrapped in protective film to prevent damage during transport. Since models like the Smile are built primarily for the domestic market, most are shipped directly to dealerships across Japan. Before any car leaves the factory, it goes through a detailed quality inspection process. Every unit is checked for panel alignment, paint finish, and potential water leaks using artificial rain testing. Inside Suzuki's production system, automation and human skill work side by side. Robots handle repetitive, high-precision tasks like welding and painting, ensuring consistency at scale. Meanwhile, human workers focus on more complex and flexible jobs, installing wiring, fitting doors, and performing final inspections. That human element is especially important in the last stages. Details like door alignment, paint quality, and overall fit and finish still rely heavily on trained eyes and hands. Workers are also cross-trained, meaning they can move between stations as needed, helping keep the line efficient and adaptable. Right now, you're looking at how Suzuki prepares the next generation of the Suzuki Jimny for production. Before assembly even begins, the vehicle is put through a demanding mix of laboratory simulations and real-world testing. These tests are designed to make sure it can handle harsh environments and tough driving conditions, staying true to its reputation as a capable off-road machine. These rolled steel coils are fed into stamping machines, where they're precisely pressed and shaped under immense force into individual body panels. Each panel is carefully formed to meet exact specifications, ensuring consistency, strength, and a flawless surface finish. Inside this factory, every Honda N-Series vehicle is built. The standout is the Honda N-Box, which has been Japan's best-selling passenger car for several years running. Last year, combined sales of the N-Box, NWGN, N1, and N-Van reached about 288,000 units. These models are sold almost exclusively in Japan. Honda N-Box has also dominated the K-car segment, holding the #1 spot for at least 11 straight years, a clear sign of its lasting popularity. You're inside the welding shop at Honda's Suzuka factory in Mai Prefecture, Japan, where robotic arms precisely assemble vehicle components with high efficiency. Steel coils are first stamped into parts like doors, inner roofs, and floor panels. Then hundreds of robots weld those pieces together with extreme precision, forming a rigid, high-strength frame designed for safety and durability. Afterward, each body is scanned with lasers to ensure it meets Honda's exact standards. Since its debut in 2011, total production of the Honda N-Series has surpassed 4 million vehicles, reflecting its strong and sustained popularity in the key car segment. Within this lineup, the Honda N-Box has played a particularly significant role, becoming one of Japan's best-selling models thanks to its efficient use of space and practicality. Every Honda N-Box has been built exclusively at the Suzuka factory since its launch in 2013, where dedicated production lines ensure consistent quality and precision throughout the manufacturing process. Today, this facility serves as the main production hub for Honda's N-Series K cars, including the N-Box, NWGN, and N1. The Honda NWGN is a KUI car, a uniquely Japanese class of small, lightweight vehicles. These cars benefit from lower taxes and insurance thanks to strict limits on size and engine displacement. Before an N-Series body is painted, it goes through several anti-corrosion treatments to protect the bare steel and ensure long-term durability. Next, sealant is applied to key joints and critical areas, and the body in white moves into the paint shop. There, multiple layers are applied: primer, base color, and clear coat, using advanced robotic systems that deliver a consistent, high-quality finish while minimizing environmental impact. At Honda's Suzuka plant, robots handle most of the spraying to ensure even coverage across every surface, while conveyor systems move each body smoothly through every stage of the process. Once the body exits the paint shop, it undergoes rigorous quality inspections to confirm the finish meets Honda's strict standards. Minor polishing removes any dust or imperfections, and in rare cases, skilled technicians perform precise touch-ups. This Honda car is built on flexible production lines that can switch between different N-Series models. This allows Honda to maximize efficiency while maintaining high output in the compact KE car segment. The Suzuka plant has produced both the first-generation N-Series, built from 2013 to 2019, and the current generation model, which has been in production since 2019 and continues to be manufactured there today. You're now watching the production of the crankshaft and the assembly of the compact engines used in Honda's N-Series vehicles, where precision machining and careful assembly ensure each unit meets strict quality standards. The N-Box uses a key car engine, typically a 660 cubic centimeter inline 3, designed to maximize efficiency while complying with Japan's strict K-car regulations, which limit both engine displacement and vehicle size. Key components such as the crankshaft, pistons, and valve train are engineered to withstand frequent start-stop conditions and short-distance driving, which are typical in Japanese urban environments. Even with their small displacement, these engines provide reliable performance suited for city use while maintaining excellent fuel economy and low emissions. Honda applies the same core engineering principles used in its larger engines, emphasizing durability, precision manufacturing, and long-term reliability with minimal maintenance requirements. Despite their compact size, the engines are tuned for smooth and quiet operation with reduced vibration, delivering a surprisingly refined driving experience for a K-class vehicle. Some versions of the N-Box are also available with a turbocharged engine, which increases torque output to better handle passengers, cargo, and highway driving while still maintaining strong fuel efficiency. K-cars like the N-Wagon are primarily designed for the Japanese domestic market, where strict regulations on dimensions and engine size make them highly practical for crowded cities, but less suited for most global markets. Now, you're seeing the main assembly line, where all components of the N-Series vehicles come together step by step into a fully finished car. This worker uses a robotic manipulator arm to quickly install the entire dashboard assembly into the car in a single, highly controlled motion, ensuring perfect alignment with the vehicle's interior mounting points. K-cars are a uniquely Japanese vehicle category created by the government to encourage affordable, space-efficient transportation in densely populated areas. They are extremely popular in Japan due to their low ownership costs, tax advantages, easy parking in tight urban spaces, and highly efficient use of interior space, despite compact exterior dimensions. Honda's K-car lineup is known as the N-Series, introduced in 2011, and it includes models such as the N-Box, NWGN, N1, and N-Van, each designed to serve different everyday mobility needs while staying within K regulations. On the assembly line, you can also see the high level of efficiency in component installation, such as the front grille being fitted quickly and precisely here on an N-Wagon, highlighting the highly standardized and streamlined production process. K-cars aren't low quality, they're highly optimized for Japan's dense cities, narrow roads, tight parking, and practical needs like delivery work and small families. They're rarely sold outside Japan because their small engines aren't suited for many highway conditions abroad, and their tax and insurance advantages don't apply elsewhere. For that reason, Honda does not officially export K-cars, though some are privately imported by enthusiasts. Despite their size, Honda K-cars are known for strong reliability, excellent fuel economy, 50 miles per gallon, low maintenance costs, and strong resale value in Japan. Now, these newly assembled Honda N-Wagon models move into final inspection, where workers check key systems like lights, brakes, engine performance, horn, and wipers, along with overall fit and finish. You are now watching dynamometer testing, where the engine's performance is measured. After final quality inspections, the Honda N-Series vehicles are parked in a massive lot next to the Ujina Factory. At the scheduled time, they're loaded onto trucks and shipped to dealerships across Japan. Each year, more than 250,000 vehicles from the N-Series are produced, with nearly 200,000 of those being the Honda N-Box. Honda K cars are extremely small by US standards, about 11 feet long and under 5 feet wide. Despite their size, smart design makes them feel surprisingly roomy inside. This is the Hiroshima plant in Japan, where the Mitsubishi EKX yellow Fanuc robotic arms handle the body-in-white welding process on the production line. The plant produces both the EKX and the Nissan Sakura on the same shared assembly lines. After the stamping process, workers carefully inspect body parts using LED lamps to check for any defects and ensure surface quality. The Hiroshima plant has about 3,300 employees. This includes workers across body welding, painting, assembly, and quality inspection. At this stage, the body in white is submerged in an anti-corrosion bath as part of the pre-treatment process. It then moves through a coating line where multiple layers of paint are applied. Finally, Japanese workers carry out another detailed quality inspection to verify the paint finish before the vehicle continues down the production line. The electric drivetrain is front-wheel drive, producing about 47 kilowatts and 195 Newton meters of torque. The platform is designed specifically for EV use, featuring an underfloor battery layout and a shared structural architecture. Right now, you are looking at the main assembly line of the Mitsubishi EKX. This is where key components such as the battery pack, dashboard, wheels, and interior are brought together into a complete vehicle. The key goals of this production system include low-cost EV manufacturing, high domestic output, and optimized compact vehicle design. A total of 100,000 of these K cars have already been produced at this facility. The EKX reflects a Japanese EV philosophy that treats electric vehicles as normal cars. It is designed to look and feel like a regular K car without major production changes. Designed for affordability rather than performance, it represents a lean and scalable EV approach tailored for urban markets. Right now, you're watching the disassembly of Honda's V10 Formula One engine that helped power McLaren's dominance and contributed to the 1990 World Championship era. This engine is widely remembered as a perfect balance between V8 engines, which were light and compact, and V12 engines, which delivered smoothness and high peak power. The engineers you see here are highly experienced specialists, some of whom originally helped assemble these engines by hand more than 35 years ago. The sound of this engine has become legendary among Formula One fans, sharp, high-pitched, and uniquely resonant, often regarded as one of the greatest sounds ever produced by a racing engine. You are now seeing the engine head being carefully taken apart. This is the Honda RA100E V10, engine 805, the final Honda V10 ever driven by Ayrton Senna. These engines were known for being lightweight, powerful, and extremely reliable, allowing them to compete directly with Ferrari and Renault during one of Formula One's most competitive eras. With Honda power, drivers like Ayrton Senna and Alain Prost achieved multiple victories and championships, and McLaren Honda dominated Formula One from 1988 to 1991. This specific engine, now being disassembled, represents the end of Honda's V10 era in Formula One and remains an iconic piece of engineering history. Unlike many engines of the era that often failed, Honda's V10s were famous for lasting full race distances, which was crucial in winning championships. Engine serial V805 is the final V10 Ayrton Senna raced in Formula One, used in the McLaren Honda MP4 during the 1990 season. It powered Senna during the warm-up at the 1990 Japanese Grand Prix and later in the season finale at the Australian Grand Prix. At the time, it was standard F1 practice for engines to be returned to Japan, analyzed, and ultimately scrapped. However, because Honda was already transitioning to a V12 for 1991, V805 was preserved intact in the archives, making its survival extremely rare. Honda Racing Corporation technicians later disassembled the engine at the Sakura facility. Every component, including camshafts, pistons, connecting rods, and cam covers, was carefully preserved and placed in a custom display case with a certificate of authenticity. Beyond its technical significance, V805 represents the end of an era, the final V10 raced by one of Formula One's greatest drivers, and the peak of the dominant Honda-McLaren partnership. In 2025, Honda Racing Corporation launched its official memorabilia program with V805 as its inaugural piece. It is being auctioned by Bonhams at the Quail Auction during Monterey Car Week on August 15, 2025, with an estimated value of around $100,000. The disassembly of a Honda V10 Formula One engine follows a strict, highly precise sequence, starting with the cylinder head, followed by a full strip-down of internal components, then the crankshaft assembly, and finally the pistons. Throughout the process, engineers document the exact position of every part using photos and detailed markings to ensure accurate analysis and potential reassembly. External components such as intake manifolds, exhaust headers, sensors, and wiring are removed first, with extreme care taken due to the tight tolerances of F1 hardware. The cylinder head bolts are loosened in a precise sequence to prevent warping, after which the head is lifted to expose the camshafts, valves, and combustion chambers. From there, camshafts, rocker arms, and valve springs are removed one by one. Each component is labeled and stored so engineers can track wear and performance over time. All parts are then photographed, measured, and inspected for fatigue or damage, with the data used to refine future engine designs and improve reliability. Unlike a road car engine, an F1 Honda V10 is treated as a fully documented engineering system, where every bolt and gasket is catalogued. In the case of V805, the complete disassembly process took approximately 15 hours. These engines produced around 700 to 750 horsepower in 1990, making them highly competitive for their era. Their compact, lightweight design improved overall car balance and handling. While all F1 engines are pushed to the limit, Honda's V10s were especially known for their reliability and ability to finish races without failure. Honda's involvement in Formula One has evolved significantly since its initial entry in the 1960s. In recent years, Honda has re-entered the sport, focusing on hybrid power units that combine internal combustion engines with electric motors. Honda's recent power units have been instrumental in Red Bull Racing's success, contributing to multiple World Championship titles. As the company prepares for its new partnership with Aston Martin, it aims to bring the same level of performance and reliability to its new team. This facility is at the heart of Honda's innovation, working on everything from Formula One engines to solid-state batteries and advanced mobility technologies. This factory was established in 2006 as part of Honda's strategic expansion into advanced automotive research. The engine head disassembly is now complete, and the oil is being drained. Next comes the second stage of the teardown, known as the strip-down. This engine contains around 2,000 parts in total, but in this video, it is being broken down into roughly 100 major components for inspection and preservation. The line features advanced systems covering every stage, including electrode preparation, coating, cell formation, and module assembly. Beyond automotive use, the Sakura facility also supports development for motorcycles and aircraft, focusing on scalable technologies that can be applied across different mobility platforms while reducing costs through economies of scale. F1 engines are typically used for development and then scrapped, making surviving examples extremely rare. As a result, F1 memorabilia, especially pieces linked to legendary drivers like Ayrton Senna, can command very high prices at auction. Collectors acquire them for display, museum exhibitions, or as long-term investments that may appreciate in value. These engines are also highly valued by motorsport fans and engineers for their advanced design and technology. Owning a V10 engine offers a rare opportunity to study and appreciate the craftsmanship of 1990s Formula One engineering in detail. At this stage of the teardown, you can see the disassembled gears and the engine's power transmission system. Honda's V10 engines also went through continuous development to improve both performance and reliability. In 1990, a revised V10 was introduced with optimized bore and stroke dimensions to enhance fuel efficiency and power delivery. After Honda withdrew from Formula One at the end of the 1992 season, it continued its racing involvement through Mugen Motorsports, a company founded by Soichiro Honda's son, Hirotoshi Honda. Mugen went on to develop and supply V10 engines to teams such as Tyrrell, Footwork, and Ligier, achieving notable success, including a win at the 1996 Monaco Grand Prix. Like I said before, the disassembly was meticulously carried out at Honda Racing Corporation's factory in Sakura City, Tochigi Prefecture, Japan, by the original engineers who had built the engine. After many hours of careful work, the engineers are now nearing the complete disassembly of the engine. Remarkably, despite its age and the stress it endured, almost everything remains intact. The workers on this engine operated as a well-coordinated team, with at least 2 specialists on this engine present in the room at all times. It's fascinating and truly unique to see this 35-year-old engine, the very reason McLaren ruled Formula One in the 1990s. Even after so many years, the inside of the engine is in relatively good condition, and once cleaned, it will be fully functional. Now the workers move on to the crankshaft disassembly. The crankshaft is the heart of the engine, converting the piston's linear motion into rotational force that ultimately drives the wheels. The crankshaft is designed for a 90-degree V10 layout, a configuration commonly used by Honda to balance performance and smoothness. It is typically forged from high-strength steel alloys and then machined to extremely tight tolerances to handle intense heat and stress. Each crankpin connects to a connecting rod, and in Honda's V10 engines, 10 crankpins are arranged to optimize firing order and balance. Built-in counterweights reduce vibration and help the engine run smoothly at very high RPMs. Engineers also remove excess material where possible to lower inertia and improve engine response. Each crankshaft is dynamically balanced to prevent vibrations that could destroy the engine at high speeds. Components are nitrided or shot-peened for fatigue resistance and longevity. A lightweight, well-balanced crankshaft allows the engine to rev faster, producing more power. Precision design reduces friction and wear, increasing reliability over a full Grand Prix distance. In Honda's V10 engines, the crankshaft was a key reason they were both powerful and durable, helping McLaren dominate in the early 1990s. Now you are watching the disassembly and removal of the pistons. Pistons transfer the force of combustion from the fuel-air mixture into mechanical motion. In a V10 F1 engine, each piston moves at extreme speed, working in sync with the crankshaft to deliver smooth, high-power output at up to 13,000 revolutions per minute. Each piston is inspected for microscopic cracks or defects to prevent catastrophic failure. In a V10 layout, the firing order is precisely engineered to minimize vibration and improve smoothness. During operation, pistons must withstand extreme combustion forces, often exceeding 200 bar and temperatures above 300 degrees Celsius. In Formula One, pistons are typically inspected after every race for signs of wear, scuffing, or heat damage. Their lightweight and precise balance allow the engine to rev faster and produce more power, while reducing friction improves reliability and consistency. In Honda's V10 engines, piston design and manufacturing quality were key contributors to McLaren's dominance in the early 1990s. They are typically made from forged aluminum alloy for strength and low weight. Pistons are precisely shaped to optimize the combustion chamber for maximum power output. Some are coated to reduce friction and heat transfer, improving both efficiency and durability. Extremely tight tolerances, measured in thousandths of a millimeter, ensure a perfect seal against the cylinder walls, which is critical at very high RPMs. As shown in this video, no robots were used during disassembly. The team relied entirely on hand tools such as screwdrivers, small hammers, and precision equipment. Formula One engines like these were, and largely still are, assembled and serviced almost entirely by hand. This engine was sold at the Bonham's Quail auction during Monterey Car Week on August 15, 2025, achieving a final price of $254,000, including fees and commissions. It was offered without reserve, with pre-auction estimates between $80,000 and $120,000. The sale marked the first piece in Honda Racing Corporation's new memorabilia program, aimed at allowing fans to own authentic motorsport history. Now, all components of the disassembled engine are laid out together. They have been cleaned and prepared for documentation before the engine is eventually reassembled.